Today we're going to start a new lesson, lesson 4.3 in your text, and we're actually going to break this up into 2 different days. The overall topic is dividing polynomials, but we're actually going to look at actually 2 different methods for dividing polynomials, and we're also going to be doing division with a monomial into a polynomial. So today the biggest part of this lesson is going to be on using long division to divide polynomials. So let me go ahead and get started and giving you some samples like your homework will be. As I mentioned, some of what you're going to be doing tonight will involve a monomial, which is here for CDF. Notice there are no plus or minus signs. This monomial is going to be divided into this polynomial. So polynomial, of course, poly means many, nomial means terms. You can see this is really 3 different monomials strung together with plus minus signs. So not too difficult to do these. You've actually done this before. For example, when you find a GCF and you divide by that GCF into every term, that involves division by a monomial. So it would look like this. We're basically just going to divide 4 CDF literally into each one of these terms separately. And let's see what the result is. 20 divided by 4 is 5. If you divide like bases, like we are here with C, remember the exponent property that says you subtract the exponent. So that's going to be c to the 4 minus 1 power, which is c to the third. Same property involved here. D to the second divided by d to the first is d to the first. F to the first divided by f to the first, that's like f to the 0. And remember, anything to the 0 power is just 1. So there's no need to write factor 1. Or in other words, we would say that the f's would cancel. Alright, moving on to the next term. 16 divided by 4 is 4. C's would cancel, D's would cancel. F squared divided by f is f to the first. Takes care of that. And then here at the last, it's really everything cancels. Any number divided by itself is just 1. And so that ends up being our final answer for this example 1a. I wanted to show you a problem like this. You'll run into this occasionally in this assignment, and just wanted to give you a heads up about what this means. Remember negative exponents. I could rewrite this changing the negative exponent to a positive. And if I did, it would look like this. Remember, negative exponents mean to write the reciprocal of the base here being 3xy. The reciprocal of 3xy is 1 over 3xy. And when you multiply by a fraction, it's really the same thing as division. Okay? So there's no difference between what I'm showing here and what I'm showing here. So just in case you saw that in your book, remember multiplying by a fraction is really the same thing as division by its inverse. So now we can do what we did before. Divide everything by 3xy. And when we do, we're going to get 18 divided by 3, which is 6. X squared divided by x is x to the first. The y's would cancel. Okay, 27 divided by 3 is 9. X cubed divided by x is x squared. Y squared divided by y is y to the first. And then we have this lone z. And so that would be the answer to this division problem. Okay, so just the big thing here is alerting you as to what this means in your problems when you work on them. Okay, now we get to a different type of problem. Example 2 is going to involve dividing polynomials. We have one polynomial dividing into another polynomial. Okay, so if it's monomial division, we do not need to use long division, but if it's anything above, binomial or above, that we're dividing by, we need to use the long division process. So here's how long division works. Remember long division, you learned it years ago when it was just regular numbers, and the same properties, the same algorithm still holds true. Looks a little different because we're dealing with algebraic expressions, but the concept is really still the same. You always divide the first term, in this case x, into the first term. That's really where the division takes place. First term here divided into the first term. So x divides into x squared x times. So you notice that I'm writing as I write my answer, I'm writing above like terms. Okay, just if I had put x here, these are not like terms. They don't match. So this is the proper way to show your answer. Now that I've decided or figured out that x goes into x squared x times, I'm going to multiply x. It's really like doing this. I'm going to multiply x times both of these terms in this binomial. Okay, so when I do x times x, I get x squared, and when I do x times negative 3, I get negative 3x. And now, just like in old-fashioned long division, we need to subtract, and I always do this as a reminder. I suggest you do the same thing. It really doesn't take that much effort, because a lot of mistakes are made at this point in the subtraction process. Now I have a reminder that when I subtract, first of all, the x squares just becomes 0. X squared minus x squared is 0. But it's usually right here where a problem develops. And now I've got a reminder that I'm doing 7 minus negative 3. Okay, some people without this little reminder, without the parentheses, I see it quite a bit. The temptation is to do this. They would say that 7 minus 3x is 4x. But once again, you got to remember that you're subtracting this entire binomial, which means you're subtracting each term separately. And when you subtract a negative number, that's really like addition. So 7x plus 3x is 10x. And now the next step is to bring down the next term, and you basically repeat that process. First term, x, divided into first term, 10x. X divides into 10x, positive 10 times. So if you're not sure how I got that, it's literally doing this, 10x being divided by x. And these would cancel, and you're left with positive 10. Okay, just like we did before, I'm going to multiply 10 times both of these terms. 10 times x is 10x. 10 times negative 3 is negative 30. Alright, and I'm going to subtract. And 10x minus 10x is 0. Negative 30 plus 30, also 0. So in this case, I do not have a remainder. And so my answer is, I'll just circle it here, x plus 10. Okay, let's do another one of those. This time I'm dividing x minus 1 into the trinomial x squared minus 13x plus 12. And so again, it's first term divided into first term. X divided into x squared goes x times, and I'm just going to write my result with overmatching like terms. Okay, now I'm going to multiply x times x, x squared, x times negative 1, negative x, subtract. The x squares cancel, becomes 0. Negative 13 plus 1x. Remember, minus negative means plus. Negative 13 plus 1x is negative 12x. Bring down the next term. Alright, now divide again. First term x into first term, negative 12x. And that should be minus or negative 12. Multiply negative 12 times x. Negative 12 times negative 1, positive 12. Subtract. Negative 12x plus 12x, that's going to make 0, or they'll cancel. 12 minus 12 also makes 0. So once again, we have a 0 remainder, and my answer is x minus 12. All right. Here's another one of those cases where we're multiplying by an expression raised to a negative 1 power. Well, just like I showed you earlier, all we are really doing is dividing by this. Multiplication by this expression really means division by 2 minus a to the first power. So another thing that has to happen, though, for this long division to take place, in cases like this, you need to turn this around so that the variable is first. And when I turn this around, I just need to be careful that the signs are still the same. Otherwise, I'm going to create a different expression. So notice that the a in my original problem has a negative sign in front of it, or subtraction. It still should have negative in front of it when I turn it around or switch it. 2 is positive in the parentheses, so it still should be positive when I switch it around. Okay, and now we're going to set up the long division process. So a cubed plus 2a squared plus 4a minus 9. And once again, we divide negative in, or first term, it is negative, but it's the first term, into the first term. And a to the third, so here's literally what we're doing, a to the third divided by negative a. Well, when you divide a positive by negative, it's got to be a negative result. Okay, we know we're going to have a negative result here. And once again, a to the 3 minus 1 power, that's a to the second. Okay, so we understand why it's negative, positive divided by negative, and then we just applied our rule of like basis subtracting the exponents. Alright, so now we're going to multiply negative a squared times both of these terms. Negative a squared times negative a is positive a cubed. Negative a squared times 2 is negative 2a squared. Subtract. The a cubes will cancel. 2 minus negative 2, that's really 2 plus 2, is 4a squared. Bring down the next term and repeat that process. First term divided into first term. This time, if you need to see it, if you need to write it off to the side like this to give you a better picture, that's certainly okay. We're going to have a negative result because positive divided by negative, so that's going to be negative 4 over negative 1. And then for the a, the variable, it's a to the 2 minus 1 power, a to the first. Now multiply negative 4a times negative a. It's 4a squared. Negative 4a times 2 is negative 8a. Subtract. A squares cancel. 4 minus negative 8a is 12a. Bring down the next term, and let's go through this one more time. Negative a, if you can't see this mentally, then off to the side, put 12a being divided by negative a. Well, that's got to be a negative result, right? Positive divided by negative. The a's here would cancel, and we're left with negative 12. Negative 12 times negative a is 12a. Negative 12 times 2 is negative 24. And we're going to subtract. And we're left with a remainder this time of 15. So the way we write remainders with polynomial division, it'll be like this. We'll say plus, and then we're going to put the remainder, which in this case is 15, over this divisor, which in this case is negative a plus 2. Or you could have put it over 2 minus a, which is the same thing. So that becomes the final answer for 2C. Okay, this one's a little different, and you really need to be on the lookout for these cases where we jump an exponent. Here's what I mean by that. We start off at fourth power, then we drop down to third power. We're okay there. But all of a sudden we went from third power all the way down to first power. We just completely skipped over, or we do not have a quadratic term. So in cases like this where you've got a missing term exponent, we're going to plug in what I call a filler term. Here's what that looks like. 6b to the fourth minus 8b cubed. In place of that missing squared term, we're just going to insert it's really just a place filler. It has a value of 0, because 0 times anything is just 0. So I'm not changing the value of the problem, not changing the problem at all. It's just going to allow us to line up our like terms when we go through this division process. So just be on the lookout if you jump over exponents like we are here, and it could be more than one. You just need to fill in with a 0 term for whatever that exponent is. But the rest of the process is just like we did before. First term divided into first term. When you divide b into 6b to the fourth, that should be 6b cubed. Multiply 6b cubed times b is 6b to the fourth. And 6b cubed times negative 2 is negative 12b cubed. Subtract 0. And then here it's negative 8 plus 12b cubed. And that's 4b cubed. Bring down the next term, that 0 term, and repeat. b goes into 4b cubed, 4b squared times, multiply 4b squared times b, 4b squared times negative 2, subtract, b cubes will cancel, 0 minus negative 8, that's really 0 plus 8, b squared. Bring down the next term, and now we're dividing b into 8b squared. So once again, if you have to do this, just do 8b squared over b and simplify, and you should see that that's 8b to the first. Now multiply 8b times b, 8b squared. 8b times negative 2 is negative 16b. Subtract. 12 minus negative 16 is really 12 plus 16, which is 28b. Bring down the last term. See if we can squeeze this in here. b goes into 28b, positive 28, and now multiply. 28b. And 28 times negative 2 is negative 56. And when we subtract, negative 14 plus 56 is 44. So we're going to show our remainder as plus 44 over b minus 2. And that ends up being the answer to example 2D. And I got one more. Okay, once again we've got this multiplication by an expression raised to the negative 1 power, so really just means we're going to divide. In this case, we're dividing by a trinomial, x squared plus 2x plus 4. We also have that case where we're missing a term, we're missing the quadratic term again, so we're going to fill in a 0 term just for spacing purposes. 4, 3, 2, 1, constant. All right, but the process remains the same. Divide the first term into the first term. So divide x squared into x to the fourth. That goes x squared times. Now multiply. X squared times x squared is x to the fourth. X squared times 2x is 2x cubed. X squared times 4, 4x squared. And subtract. The x to the fourths cancel. Negative 1 minus 2 is negative 3 x cubed. 0 minus 4 is negative 4 x squared. Bring down the next term. And now divide. X squared goes into negative 3x cubed, negative 3x times. So once again, if you struggle with that just a little bit while you're still getting used to it, it's basically simplifying this little expression, negative 3x cubed being divided by x squared. And when you do the subtraction of like bases, you get x to the first, and it's really just negative 3 over 1. Okay, so now let's multiply. Negative 3x times x squared, negative 3x cubed. Negative 3x times 2x is negative 6x squared. Negative 3x times 4 is negative 12x. Subtract. And the x cubes cancel. Negative 4 minus negative 6, that's positive 2x squared. And negative 8 plus 12 is positive 4x. Okay, now we're going to divide x squared into 2x squared. And that's positive 2. 2 times x squared. Oh, I forgot to bring my next term down. Sorry about that. 2 times x squared. 2 times 2x. 2 times 4. And we're going to end up with one of those zero remainder cases here. So my final answer for letter E is x squared minus 3x plus 2. So those are some samples of the types of problems you're going to be doing on the assignment tonight. And so let me know if there are any questions you have. Bring your completed work to class and we'll see how you did. And we'll see you next time.